All right, Ninja Nerds, in this video we are going to talk about deglutition or swallowing. It is an extremely important process. And the reason why is if you think about it, in order for us to be able to absorb, for example, the nutrients from a piece of pizza, we have to be able to chew on the piece of pizza. We have to mix it with the saliva. We have to be able to swallow it in order for it to pass from an oral cavity to a pharynx, to the esophagus, to the stomach, and then eventually into the duodenum where we can absorb those nutrients. So it is an extremely important process and clinically relevant. All right, so now what we're going to do is we're going to talk about specifically the 3 phases of deglutition. So let's go ahead and get started. All right, so the first phase that we're going to focus on is the oral phase. So here's one thing I want us to understand. It's not just important to note the physiology of these entire pathways, the oral, pharyngeal, and esophageal phase. It's important to have a little bit of understanding of your anatomy. So when we talk about oral phase, it's obviously the events that are occurring within the swallowing process that are specifically focused within the oral cavity. But we should understand, where does the oral cavity begin and where does the oral cavity end? So the oral cavity specifically, so I want us to understand like the boundaries. So if I were to talk about the oral cavity boundaries, I think that is really important for us to understand here. So the oral cavity boundaries. The first thing is anteriorly. So if we go to the anterior part, there's a space between the lips and the teeth. They call that the oral vestibule. So anteriorly, it's bordered by the oral vestibule. So anterior, it is actually bordered by the vestibule, oral vestibule. Okay, cool. So that's the anterior boundary. The posterior boundary, we'll get a better look at this later when we take an anterior view of the oral cavity, but there's an arch right here in the back part of the oral cavity. It's called the palatoglossal arch. The palatoglossal arch is the posterior boundary of the oral cavity. So the posterior boundary is going to be the palatoglossal arch. And like I said, we'll get a better view of this when we go over to the pharyngeal phase because we'll get to see a nice anterior view of the oral cavity. Okay, so that's the boundaries. The next thing we should understand, before we even get into the events that are occurring inside of the mouth, what do we have to do in order to put food into the mouth? We have to open up the jaw. So in order to depress the mandible, bring the mandible down so that we can fit a piece of food into our gully, is we have to have muscles that are going to depress the mandible. So what are some of those muscles that will depress the mandible? All right, so what are some of these muscles? One of the big ones that I really want you guys to understand here is going to be the lateral pterygoid. The lateral pterygoid is really important because he has a bunch of different functions, but we're focusing primarily on the depression of the mandible. So he depresses the mandible, so he opens up the jaw. Now another thing is we should not only just know the muscle, but what nerve is innervating this guy. This is primarily cranial nerve 5. But when we talk about this, there is actually going to be a bunch of divisions of cranial nerve 5. One is there's actually the ophthalmic, the maxillary, and the mandibular. The mandibular is the 3rd division, so we can put a 3 here to represent that this is the 5th cranial nerve, 3rd division, which is also the mandibular nerve. Another one is going to be the digastric. So the digastric anterior belly. This is another one. The digastric anterior belly, if the hyoid is in a fixed position, it can also depress the mandible. And this is also innervated by cranial nerve 5. And this is going to be, again, the V3. The V3 is going to be the motor branch of the trigeminal nerve. The ophthalmic and the maxillary are more for the sensory functions. Another one is going to be the mylohyoid. And the mylohyoid muscle is also innervated by the trigeminal nerve. So we'll put cranial nerve 5 here. And again, this is the V3 division. The last one is called the geniohyoid. And the geniohyoid is actually innervated by the cervical plexus, primarily that of the C1 ramus, okay? So this is innervated by the cervical plexus, but primarily by the C1, part of the cervical plexus. All right. So all of these muscles are going to contract to depress the mandible. Now here's the cool thing. When you depress the mandible, you bring the mandible down, right? It stretches the antagonistic muscles to the depressors, the elevators. When you stretch those muscles, it activates muscle spindles. Those muscle spindles are proprioceptors, and they respond to the stretch on the muscle. When they're stretched, it activates the afferent fibers of the trigeminal nerve and sends that to the brainstem, activates the motor fibers of the trigeminal nerve. It comes out and causes the activation of the elevators. And when you elevate the mandible, boom, it'll bring it up. Because the whole purpose is we were depressing to open up the actual jaw to put food in. The food's in the mouth, bang, we crunch the food with the actual action of the elevators of the mandible. What are some of those muscles? One is going to be the most powerful muscle, which is the masseter muscle, okay? The next one is called the temporalis. And this is a very interesting muscle too, okay? This elevates the mandible and elevates the mandible. The next one is going to be called the medial pterygoid. I don't know why I have a fourth one there, okay? But we got masseter, temporalis, and medial pterygoid. What's nice is that all of these muscles are innervated by the trigeminal nerve, which is cranial nerve 5, and again, this is the third division. Okay, this is actually going to be the third division or the mandibular division. Now, when we depress the mandible by those depressor muscles, stretch it, activate muscle spindles, trigger the elevator muscles to contract and crush the food. It utilizes our teeth, because the mechanical digestion is we're just trying to, there's a whole bunch of different things with mechanical digestion. You're not breaking any chemical bonds, you're just trying to break the food down into smaller pieces. Well, our central incisors and lateral incisors are good for like cutting or nipping at pieces of food. The canines are good for tearing or piercing into the food. And the molars and premolars are good at being able to grind and crush the food. So the combination of our muscles of mastication and the teeth, what are we doing? We're breaking a big food molecule like a piece of pizza down into smaller pieces. That's really good because there's an important reason for that, and we'll talk about it after the salivary glands. But the last thing is once we activate those muscles and those muscles contract, there's pressure receptors that can pick up, and they're in the oral mucosa, the gingiva, even the tongue. And whenever there's a high pressure from you pushing down on that food, it activates nerves, sensory nerves, that go to the actual brainstem and inhibit the trigeminal nerve. And the motor fibers going to the mandible elevators will be inhibited. If they're inhibited, what will happen? They'll relax and the mandible will drop back down to a resting position. That's one of the cool things about this. Next thing is, not too much about this, just realize that you have salivary glands. And there's two types. There's intrinsic, which only account for about 10% of the salivary secretions, and the extrinsic. And this was the one that was the parotid, the submandibular, and the sublingual salivary glands. And this accounts for about 90% of the salivary secretions. But more important than that is, what is the purpose of this saliva? The muscles over here, pretend here's a bolus, and we make our way here. Here's a piece of food. So here's a big glob of food. And they get broken down by this chewing process. When they get acted on by these muscles here, it breaks the big food particle down into smaller food particles. Then what happens is the saliva is going to lubricate all of these actual food particles. And there's mucin molecules and different types of digestive enzymes that will combine with this, moisten the food, lubricate the food, soften the food, and make it more into a nice compact mass. So it's not so big. And that little mass that we now have here is going to be called a bolus. Okay? There's two reasons that I wanted to mention this. By doing this process, mastication and the salivation mechanisms, it gives us two really important things. One is it increases the surface area for chemical digestion. Okay, and this would be by salivary amylase, which is a carbohydrate digesting enzyme, and lingual lipase, which is a fat digesting enzyme. And the other one is it decreases abrasion of GI lining, particularly the pharynx and the esophagus. Try imagining swallowing a potato chip whole. You're going to frick your stuff up. That's not what you want. Okay, so that's the big thing that we want to know here for that process. Now, let's assume that we've done these things thus far. We've done these events, so now we took the big bolus, the big piece of food, we ingested it, we broke it down by the mastication process, we mixed it with the saliva, and now it's a nice compact mass here, which we're going to refer to as a bolus. The next event that has to happen is we need the tongue to take on a special shape. So you have muscles of the tongue. They're called intrinsic muscles of the tongue. And what they do is they change the shape of the tongue in such a way that they form like this central trough. It's like a longitudinal central trough. So imagine here's the tongue, and here's my little trough here. That's one thing that the intrinsic muscles of the tongue are going to do. They're going to form a central trough. The next thing is there's going to be other muscles, and these are the extrinsic muscles of the tongue. And the extrinsic muscles of the tongue are actually going to elevate the tongue so that the tip of the tongue touches the actual palate. That's so cool. So not only have we formed this nice little longitudinal look, we can do it like this actually. Look, this is actually a lot better. Here, we'll have the tongue up like this, and then we'll have imagine a little tunnel there. There's a little kind of longitudinal tunnel. The bolus is sitting right here in this. Okay? So two things have happened. One, we elevated the tongue. So we had to elevate tongue. Second thing is we had to form a trough. So the second thing here is we had to form central trough. The elevation of the tongue is carried out by the extrinsic muscles of the tongue. And the central trough is formed by the intrinsic muscles of the tongue. And we'll label these when we go over there, of tongue. Okay, cool. Now, once we've done that, we have the actual tip of the tongue at the hard palate. Look what this does. There's a whole purpose to this. It creates a nice little downward slope. So there's a little slope that this bolus can just be whee, right down into the pharynx. So we create this downward slope that'll allow for this bolus to move posteriorly into this area, which we're now going to refer to as the oropharynx. So that is the significance of elevating the tongue and forming a central trough. The whole purpose is to create a downward slope. That is the significance there. So now, oral phase, we had the boundaries. Next thing is we have to have the mastication process. Okay, and remember, there's 4 muscles of mastication. We mentioned a lot over here, but the main ones that are involved: lateral pterygoid, medial pterygoid, masseter, and temporalis. And remember, all of these were innervated by the trigeminal nerve, and if you really want, the actual third division or the mandibular division. So that was significant. The next thing that we had to remember is the salivation process. And the whole purpose of the salivation was helping for 2 things. One is the chemical digestion of the food. Okay, and that was the carbohydrate process of salivary amylase and the lipid breakdown by lingual lipase. And the next thing is to actually soften the food. Okay, and form that nice compact mass called a bolus. And the last thing that we wanted is we wanted those intrinsic and extrinsic muscles of the tongue to be able to contract. And the whole purpose of that was to create a downward slope of the tongue. And again, if you wanted to remember, the intrinsic muscles and extrinsic muscles of the tongue are innervated by cranial nerve 12, which is also known as the hypoglossal nerve. If you really want to know really quick, the extrinsic muscles of the tongue that elevate the tongue is primarily the styloglossus and the genioglossus. The intrinsic muscles of the tongue are like the superior longitudinal, inferior longitudinal, vertical, and transverse muscles of the tongue. Okay? Another muscle that can help in this creating the elevation of the tongue is also the mylohyoid too, if you wanted to know that also. But again, trying to get the basic parts here. So that is what we consider to be a part of the oral phase. Now here's what I want you to know before we get into the next diagram. Remember I told you that it was bordered, the posterior border here. I'm going to create like a little border here. This we said is the palatoglossal arch. Once the bolus comes into contact, I mean he just even touches this area here, boom, we are no longer in the oral phase. We're going to go into the pharyngeal phase now, okay? So that is what I want you to remember. Once the bolus touches this palatoglossal arch, we are no longer in the oral phase, and now we're going to go into the pharyngeal phase. Okay, so now we have to hit the pharyngeal phase. So what did I tell you before? I said it had to first hit what structure? The palatoglossal arch. So now what I need to do before we continue to go on throughout the pharyngeal phase is you need to know what is the palatoglossal arch. So come over here a little bit with me and look at this structure here. So what you're looking at here is you're looking at, this is the lips, right? Lower, upper lips. And you're looking into the oral cavity. Like if I had you guys open your mouth and you're looking in, I'm looking in, this is what you're gonna see. This little sucker right here, the frickin' speed bag, that's your uvula, okay? Then there's an arch right next to it. This one right here and that one right there. The one towards the midline in this case. But really, in reality, it's in the back. This one right here, this arch. So I'm going to put here 1, okay? Then I'm going to put here 2. 1 is specifically the palatopharyngeal arch. And 2 is the one that's a little bit more anterior. That is the palatoglossal arch. Remember I told you, once you hit number 2, the palatoglossal arch, we are no longer in the oral phase, we're in the pharyngeal phase. There's a reason why. There's a bunch of nerve fibers, a bunch of different sensory receptors that are super, super concentrated in this area here, at the palatoglossal arch, the palatopharyngeal arch, even in between. So you see how there's a space where these little green structure is? That space right there, we'll write that down here in a second, but that space right there is even called the tonsillar fossa. So here, look, I'll put number 3. That little space in there, that space is called the tonsillar fossa. That area, and even one more area, which is the posterior pharyngeal wall. All of these structures are super, super innervated by a special cranial nerve. That cranial nerve is going to be the glossopharyngeal nerve, or cranial nerve 9. So this is what happens. I want you guys to imagine, I'm just going to put it kind of like in this area. I'm going to put like a nice blue fibers here. And these blue fibers are just literally representing all of these fibers right here. I just don't want to get the diagram too cluttered. And I'm going to bring this up here. It actually goes to a special ganglion and then goes into the central nervous system. And again, what is it picking up? Remember what it touched? What touched this area right here? Look here. This guy right there. This little dude right here, that's our bolus. So once it touches, it stimulates the glossopharyngeal nerve fibers, the afferent fibers. Once it does that, it stimulates action potentials down this axon and goes into the central nervous system. So these fibers, they're going to come up into the central nervous system and they're going to activate, technically they will activate a bunch of other structures like the nucleus attractus solitarius, which then can stimulate the nucleus ambiguus. But what I want you to remember is this glossopharyngeal nerve is going to lead to the activation of another cranial nerve, vagus nerve. Cranial nerve, 10. Now remember, the nucleus there is technically the nucleus ambiguus, but again, we're not trying to overload ourselves with that. We're just focusing on afferent fibers of the glossopharyngeal nerve here are being stimulated. Cranial nerve, 9, coming up, activating the vagus nerve. The vagus nerve is then going to come down and do a bunch of different things. But before I start going in and telling you all the different things, here's what I want you to do to make your life 10 million times easier. Think about where the bolus could go from here. It technically has 3 different areas that it could go. It could go up into the nasopharynx. Up here is the nasopharynx, right? It could go where it's supposed to go, which was down into the pharynx and then eventually into the esophagus. Or the bolus could, not good though, could go down into the larynx, and we don't want that. So technically there's 3 destinations of this bolus. Let's focus on each one individually. So first thing is, we're going to focus on this one now. The first one is, how do we prevent food from going up into the nasal cavity via the nasopharynx specifically? So let's go ahead and do that. Okay, so let's say that the bolus is right here then. Here's our bolus dude. And he's like, woo, don't want to go into the nasopharynx. So what happens here? Remember that we said it'll activate the palatoglossal arch, palatopharyngeal arch, the tonsillar fossa, the posterior pharyngeal wall of these nerve fibers. And again, if you want to remember, you go back, you can say this was cranial nerve 9, the glossopharyngeal nerve. Stimulated it, sent action potentials into the brainstem, into the medulla, and eventually leads to the activation of cranial nerve 10, the vagus nerve. Now, what the vagus nerve is first going to do is it's going to come out here, and it is going to stimulate this muscle here. So here, let's do this in red so we know that it's a muscle. Look, we're going to have this guy right here. Let's actually do him in this maroon color so we can distinguish him. So here's our little punching bag right here. Here's the uvula. We're going to stimulate the uvula and cause the uvula to contract. Now watch what happens. If this guy contracts, he's going to go upwards. If he goes upwards, now this is the next position. So this was the first position pointing down. Now he's going to go up. Look what he just did. If he goes up here, it's going to be hard for the bolus to get up into the nasopharynx. Such a beautiful mechanism. So now that's one thing. So the first thing that I want you to remember is activation of the uvula. Uvula lifts up, blocks off the nasopharynx. Second thing is it goes to this muscle right here. There's muscles of the soft palate. This one right here is called the levator veli palatini. So levator veli palatini. And when this puppy contracts, this muscle right here, it's going to elevate. It's going to pull up on the soft palate. As you pull up on the soft palate, it's going to increase the distance between the bolus and the soft palate. So not only is it going to be hard to get up into the nasopharynx, but now I pull up the hard palate, it's farther away from the bolus. We're making this impossible for that guy to get up there. Another one is, there is the trigeminal nerve. Again, the trigeminal nerve, he actually can have fibers that come out and innervate this guy. Again, this right here can be cranial nerve 5, the trigeminal nerve, and again, this is actually going to be V3, the mandibular division. It'll come and innervate this muscle. This muscle right here is called the tensor veli palatini. And what this guy does is he tenses the soft palate. If you tense the soft palate, it's going to accentuate or enhance the action of the levator veli palatini. So now it's going to elevate the soft palate even more. So 3 things total have happened. One thing is we elevated the uvula. Second thing is we elevated the soft palate via the levator veli palatini. Third thing is we tense the soft palate via the tensor veli palatini, which accentuates the action by elevating the soft palate. Boom, we prevented the bolus from getting into the nasopharynx. Amazing. Next thing we need is we need to make sure that this bolus doesn't go into the larynx. This can be extremely deadly. If a bolus goes into the larynx, it can go into the trachea, and it can cause us to choke, right? We don't want that. We don't want to aspirate. We don't want to have to do the Heimlich maneuver on anybody. So now the next thing we have to think about is, how do we prevent the bolus from saying wee and going down to this area? What do we do here? Two mechanisms. So now what we have to do is, I want to zoom in on this uvula, zoom in on the larynx a little bit better over here. So we're going to take a kind of look over the larynx over here. Two things are going to happen at this point. So let's put here first one and second one. First thing, most important thing, it always happens when we swallow. Whenever you swallow, then the food gets the right of way, okay? And naturally, there's your vocal cords, right? These little green things right here. These little green guys are called your vocal cords, your true vocal cords. Okay? And these things are normally important for like phonation. They vibrate, and whenever they vibrate, it produces buzzing sounds, which helps to produce speech. But another thing is, whenever these vocal cords, whenever food is coming down, we don't want to focus on speech. So what happens is, there's actually some muscles around this area. You know, there's a lot of different muscles around this area. And these are called the lateral, one of them is called the lateral cricoarytenoids. Okay, lateral cricoarytenoids. Another one that's also here is you have your transverse and even and the oblique arytenoid muscles. Now, so when these muscles contract, they actually approximate, or another word is adduct, the actual vocal cords. So these guys are going to approximate. Now there's a space. The space between these two, the space between the vocal cords, that space right there, it's called the glottis. So it's the space that will actually eventually lead down to the trachea. So the first thing we want to do is we want to approximate the actual vocal cords and then decrease the actual glottis. We don't want food to go down into the actual trachea. And as a result, that results in apnea. So air can't actually go down, so we can't breathe. So the small moment of time when we're actually not able to breathe when we're swallowing, it's called deglutition apnea. But again, remember, first thing here that is significant is we need to approximate the vocal cords, okay? And by doing that, that narrows the glottis and prevents food from being able to come in. So it results in the adduction. This is another word for it, besides approximating, is adducts. And that decreases the space now, and it decreases the chances of food going in. The second thing is this little flap right here. Whenever the bolus is coming down that way, it can run into this epiglottis. When it runs into the epiglottis, you know epiglottis is made up of elastic cartilage, so here's our epiglottis. It's made up of elastic cartilage, which has a lot of resiliency. It can stretch and it can recoil. So when the bolus touches this, it can actually kind of bend the epiglottis downwards. That bending is called retroversion of the epiglottis. There's another thing that happens. There's muscles. Imagine there's muscles right around this edge. They're called the aryepiglottic muscles. And when they contract, they pull the aryepiglottic folds closer to one another. And that helps to, again, accentuate the pulling back of the epiglottis. So first thing that happens, approximate the vocal cords. This is more important than the epiglottis one. Okay? Second thing is we're going to say retroversion of epiglottis. Okay, and this can be coming in contact with the bolus, or it can be via the muscles called the aryepiglotticus, which approximates the aryepiglottic folds. So that's what we want to happen here. That's preventing the food from going into the larynx. So that's that pathway. Boom, we've already covered two pathways now. The next thing is we want to make sure that the pharynx openly welcomes the food into the, we want to make sure that the pharynx openly welcomes itself into this bolus. So we want to make sure, no matter what, that this bolus doesn't go this way, but that it perfectly goes this way. So there's a bunch of muscles that help that process. Okay, what are some of these muscles? One of the muscles, and we talked about it over here. We talked about the arches. So if you look here, we have the palatopharyngeal arch and the palatoglossal arch. There's muscles around those arches, the palatopharyngeus and the palatoglossus. The palatoglossus and the palatopharyngeus, imagine these walls coming closer together. If these walls are coming closer together, it's making sure, like imagine here's like a little slit. Here's a little slit, here's a little slit. When we want to push this bolus out here, so imagine here's the bolus. We want to push the bolus out here, it has to go through this slit. Two of them, technically, if we really want to think about it. So imagine here's the first slit, and then here is the next slit. So it has to go through this one, and then after that it has to go through this one. In order for it to get through this slit, the palatoglossus will contract. When it contracts, it approximates these walls. These slits these areas come together, and it squeezes the bolus into the next segment. Then the next muscle is the palatopharyngeus. He's going to have to contract, and he'll approximate and make sure he squeezes a small bolus into the pharynx. Isn't that a beautiful mechanism? I think that's so darn cool. So remember that. So big thing to remember here is that the palatoglossus and the palatopharyngeus are going to approximate the walls to make sure that only the smallest bolus possible goes into the pharynx. The next thing is, like I said, we want to make sure that the pharynx is openly welcoming this bolus. So you know what we're going to do? We're going to bring the pharynx to the bolus. Let's do that. So there's a whole bunch of muscles over here. We're going to categorize this group of muscles. We're going to categorize just this group right here. Boom. This whole thing right here. These are the outer, like longitudinal muscles. So these are the outer, because there's two layers, circular and outer. We'll talk about the circular next. But the outer longitudinal layer. Okay? And these muscles, there's a couple of them. One is the stylopharyngeus. Another one is called the salpingopharyngeus. And there's another muscle here that we're going to talk about, because remember that muscle, the palatopharyngeus? It also is a part of this longitudinal layer here too. So not only does it approximate the walls to make sure that the bolus, smallest boluses pass through, but it can also do another function with this outer longitudinal layer. So we have the palatopharyngeus. So this is a double acting muscle, right? Approximation and this next function. What do all of these guys do? They're so gracious. They do two things. They elevate the pharynx. They pull the pharynx up, and they elevate, as a result, the larynx. So they can do two things. They can elevate the pharynx, and they can elevate the larynx. So now it's going to pull upward. And at the same time, it's going to pull the larynx upwards. So two things there with this outer longitudinal layer. Next question I have, what nerves innervate it? Vagus. So the vagus nerve is going to innervate these outer longitudinal layers. Just like the palatoglossus, it's also, if you remember down here, the palatoglossus, it's also innervated by the vagus nerve too. All right, cool. So that's one way. One way is we're going to elevate the larynx and the pharynx to openly welcome that bolus. Next thing, let's squeeze the pharynx to make sure that only the smallest, we can make sure that the bolus not only is received, but we can make sure that we can start propelling it downward. That's another thing. That's where these bad boys, these chunky muscles come in. So let me move this glossopharyngeal nerve here, because we're going to need this space right now. So now look. Here, we'll put the glossopharyngeal nerve to the side. Okay? Okay. There's this inner circular layer. Okay, so this layer here is the inner circular layer. And these are your pharyngeal constrictors. So there's the superior, the middle, and the inferior pharyngeal constrictors. I'm going to put PC, PC, PC. So you have the superior, this one, middle, and inferior pharyngeal constrictors. This is the circular layer. So now watch what happens. The bolus is going to come down. Once it comes down, these muscles are going to undergo what's called peristalsis. So they're going to undergo a process called pharyngeal peristalsis, which is just like that alternating wave of contraction and relaxation to push the bolus down. Such an amazing mechanism. So this is going to push the bolus down. Okay, one more thing that is such a cool thing that helps in this pharyngeal phase, and it's another thing that it's kind of not just with the pharyngeal phase, but it also helps to, it not only associates the food going into the pharynx, but it also, again, helps to prevent food from going into larynx also. You have some other muscles right here. These muscles here are your suprahyoid muscles. So what are these ones right here that I'm going to kind of like engulf here? This is the suprahyoid muscles. And there's a bunch of these. Digastric anterior belly. I'm not going to go over all of these. I just want you to know suprahyoid muscles. Digastric anterior belly, posterior belly, stylohyoid, geniohyoid, mylohyoid. What's the significance of this? When they contract, they pull upward on the hyoid bone. When they pull up on the hyoid bone, it pulls the larynx upward and anteriorly. So these muscles here, what's the function? What's the overall get up with these guys? So this is the third thing, is we are going to have larynx elevated and moved anteriorly. So if you think about that, if I move the larynx upward and anteriorly, it's just making sure that the food doesn't go into the larynx and it just drops right in to the pharynx. So that again is another beautiful thing. Last thing that I have to talk about here with the pharyngeal phase is at the lowermost part of the inferior pharyngeal constrictor, this one right here, there's a muscle that we say is actually a part of it. It's like the lowermost part. So here, I'm going to kind of connect these guys here, because technically these guys are actually kind of connected. So this is the inferior pharyngeal constrictor. The lowermost part of the inferior pharyngeal constrictor, there's a special muscle here, and this special muscle here makes up most of this sphincter here. This muscle is called the cricopharyngeus. The cricopharyngeus acts as this sphincter here, which is called the UES. The upper esophageal sphincter is the primary muscle of the upper esophageal sphincter. Now, peristalsis is occurring. It's moving the downward. As it goes downward, remember, as you go down, the descending axons will relax the lowermost part so that the bolus can be received. So now we want the bolus to just kind of boop, fall right into the esophagus, right? That's what we want. But not only is it just going to be the natural peristaltic mechanisms, but look what you did to the larynx. You moved it upward and anteriorly. That also opens up the esophagus too. So that's a cool thing also. So the fourth thing that I want you guys to remember is the cricopharyngeus. Who do you think he's innervated by? Cranial nerve 10, vagus nerve. When this guy relaxes due to the peristaltic mechanism, the descending axon should always relax it, and the larynx moving upward and anteriorly, it allows for the bolus to now move into the next segment, which is the esophagus. Okay, so now what we need to do is we need to kind of blow through this really quick and describe what we just said in just the most basic things. So what do we want to do here first? Prevent bolus from going into nasopharynx. That was the big thing. We don't want that, okay? Next thing is we want to prevent bolus from going into larynx. And we had all the mechanisms that we discussed there. We want to ensure bolus enters the pharynx through the mechanisms that we discussed, And the last thing is we want to make sure that the upper esophageal sphincter, UES, relaxes. That is the significant part. And if you remember the UES, we can really say it because mainly it's the cricopharyngeus. It's really the lowermost part of the inferior pharyngeal constrictor, but it makes up most of the upper esophageal sphincter. That is the primary components of the pharyngeal phase. Now, really quickly, pharynx, there's actually three parts. We talked about it in our half-head anatomy model. There's the nasopharynx, which is technically from here all the way up to the uvula. Then from the uvula all the way down to the epiglottis, like this imaginary line here, that's the oropharynx. And then from the epiglottis downward until we get into the esophagus is the laryngopharynx. So we have nasopharynx, oropharynx, laryngopharynx. So that is the borders of the pharyngeal phase. Once you hit the actual moving below the upper esophageal sphincter, we're now in the esophagus. So it's a beautiful mechanism. You should be thankful though, because the esophageal phase, thank goodness it's so easy. So now we have the bolus right here. The bolus is right here. We're having it move down the esophagus. Look, he's crying. You want to know why? Look at this. He knows there's a whole bunch of hydrochloric acid and pepsin just waiting for him. And he does not want to go down there, but sorry, buddy, you do. You're going to have to go down. So remember, the esophagus is extremely muscular. And when it contracts, its muscularis externa will contract. It undergoes peristalsis. But here's the beautiful thing. The peristalsis that was occurring in the pharynx, there's just a continuation of that down the esophagus. Isn't that so cool? So what I want you to remember here is the peristalsis that occurs in the pharynx, the ones that occur in the esophagus, is just a continuation of the pharyngeal peristalsis. So remember this right here. So the peristalsis, there's a technical word for this that we should mention. It's called primary peristalsis, is continuation of pharyngeal peristalsis. So just imagine like a wave starting at the superior pharyngeal constrictor and just traveling its way down. It not only goes down the pharynx, but the peristaltic wave goes all the way down through the esophagus. And again, remember, what nerve innervates all the muscularis externa of the esophagus? Cranial nerve 10, vagus. A lot of this area here is supplied by the pharyngeal plexus. We talked about a lot of these nerves here more in the cranial nerve videos. So if you haven't seen those, go watch those. You'll have a little bit more info on this stuff. Okay, primary peristalsis we know. The next thing that we have to know is the bolus gets here and it's kind of like squeezed. It can't get into this area. Well, remember we said there's peristalsis. As the peristalsis moves down, remember the descending most muscle here of the muscularis externa has to relax. And the ascending part has to contract so that it produces a constriction ring right here behind this bolus, and it produces an open space right here in front of the bolus right here. So now, or we can say after the bolus, down here. We want it to relax here, we want it to constrict behind it. So if that's the case then, we need this muscle right here. They call this one, there's a whole bunch of names for it. I'm going to say lower esophageal sphincter, LES. There's two other names, the cardiac sphincter and the gastroesophageal sphincter. It can be affected because in GERD it can actually come back up because of people who have like hiatal hernias, because the esophagus actually runs through the diaphragm through what's called the esophageal hiatus. So lower esophageal sphincter has to relax. Now when this muscle relaxes, guess what? Bye-bye, bolus. He is going to come down in here and look at him. He's going to be in pieces. I know this is graphic, I'm sorry. But what we're going to do is we're going to start breaking that guy down. Now here's the last thing I need to tell you here. Let's say you try to swallow like a huge hamburger whole. And you're trying to swallow it. Sometimes it happens. It happens to me a lot. But when I swallow something, sometimes it can feel like it's stuck and it's having a hard time going down. It's not that you're choking, it's just it's stuck. And the peristaltic wave, the primary peristaltic wave, just wasn't strong enough to push the bolus down. If it gets stuck, there's a really cool mechanism here. We talked about this in the enteric nervous system video. If you haven't seen it, go see it. Here, we're going to have that bolus. Let's imagine that for a second that bolus got stuck. Here it is, he's stuck. When he's stuck there, he's going to stretch, because naturally the esophagus is kind of like collapsed, but whenever food's coming down, it opens up. It's going to stretch the esophageal walls, right? And then it's going to activate these stretch receptors. Here, this purple guy right here, this is a stretch receptor. And what the stretch receptor will do is he will do two things. One is he will stimulate these blue neurons and inhibit these green neurons. What do I mean? The blue neurons are going to do what? If you remember, we're not going to go into super detail here, but it inhibited the longitudinal layer above this bolus and stimulated the circular layer above the bolus. The descending axons did what? They did the exact opposite. So now let's come to like this segment right here. It's going to do what to this one? Stimulate the longitudinal layer and inhibit the circular layer. If I do that, it will contract up here and relax right here. And this will help to ensure that the bolus moves down. That right there is called secondary peristalsis. So secondary peristalsis is basically your local reflexes. The local reflexes through your enteric. This blue and green structure is your enteric plexus. If bolus is stuck. And then also remember, a part of this primary peristalsis, I'm going to put it in kind of like a red here so we understand, is the lower esophageal sphincter relaxes as a result of this primary peristalsis. All right, Ninja Nerds, so thank you guys so much for watching these videos. I thank you guys so much. I really do. I appreciate it. I hope that you guys liked this video. I hope you learned something. If you guys did, please hit that like button, comment down in the comment section, and please subscribe. Also, I just want to take a second, guys, and just say thank you so much for supporting us here at Ninja Nerd Science. It means so much to us. We really do love to hear from you guys and hear how much we're making a difference in you guys' academic life. It means so much to me. It means a lot to our crew here. And I just thank you guys so much for that. Also, these videos would never, ever, ever be possible if it wasn't for Robert Beach, one of the guys who controls all the filming, all the editing, all the audio, all the uploading, the exporting. So guys, please throw some comments down in the comment section for this guy, because this channel would not be possible without him. All right, Ninja Nerds, as always, until next time.